I want you to like show at least in between steps here. Okay, can someone be brave, please, Austin, and tell me what sine of 30 equals, please? 1/2. Yes, I certainly can. Okay, let's draw the triangles nice and big here. Can somebody come and remind me how I do a 30, 60, 90 triangle? What do I do? Yeah, well, they're all be different. Okay, I'm going to slow down now.
It's always going to
You're always, okay, just wait. What's going to happen is these special triangles, that's called special triangles, are used whenever you have a certain angles. They're always going to be the same proportion. So what's going to happen is for my 45, 45, 90 triangle, I'm going to do this. That's going to happen always. For the other triangle,
So wait, is it fair to say that angle length dependent on angles?
okay, the question was, angles aren't dependent like they sort of are dependent on the ratio of the angles. Sorry, they're dependent on the ratio of the side lengths, right? So it's like if you do 1 and 2, that's the same as 10 and 20, right? Like they're the same.
If one length is twice the size of the other length,
Yeah,
it's always going to be 30 degrees.
yes. Okay, so those are things. So where I got sine 30 from, I looked at this triangle and said, well, there's 30 opposite over hypotenuse. Okay. Tan 45, can someone else tell me please what tan 45 equals? Go ahead. Over 1, which is just 1. This question works out beautifully. And cosecant 30, oh boy, this is too tough. What does cosecant mean again from Friday? Go ahead.
It's 1 over cos equals 2 over 3, sorry.
1 over sine.
Oh, sine.
Remember that's the one like you think cosine should go with cosecant, and so when it doesn't, that makes you angry. And human being, that's what, right? So I'm going to call that then 1 over 2 times 1 times 2. Does somebody tell me where the heck I got 1 over sine 30 is equal to 2?
Dividing fractions.
Yeah, dividing fractions flipped. Remember, it's just going to be whatever sine 30 is 1/2, and it's flipped. That's 2. So what does all this mess equal? Cool. Okay, awesome. All right, example 2. Yes. Always, yeah.
You're never going to change that.
No, I can't because that's like if you type into your calculator sine of 45, it's always going to be 1 over root 2, which is 0.707. Like your calculator doesn't change. Right? It's the same proportion. All we just proved it's always going to be the same proportion. So these two things always are going to look like that forever and ever and ever.
What if we change the side lengths, it doesn't matter?
No, well, we'll show you how to deal with that, okay? Like, as if this changed to be a 4, then that means everything's going to be twice as big. Right? Because this would be twice as big. 2 and then 2 root 3. We'll deal with that, though, in a few minutes. Let's stick with one more nice like this. Find the exact value of. So pick up the pace a little bit. Pause in the video, and I want you to try this one out, please. So again, use this as application. Again, I would try when you're doing these questions, not just to use the table, use the triangles and try and make the answers. You're not going to have that table memorized, right? So use use your fingers on the triangle and say opposite hypotenuse and all that stuff to get the answer. Yes?
How'd you get 1? Because like 1 divided by 1/2 is 2.
But it becomes.
Okay, because just think what I did here, right? So this part, this term, 1 over sine 30 equals 2. We're okay with that? Okay, so I just multiply that. 1/2 times 1 is 1/2. 1/2 times 2 is 2 over 2, which is just 1. Right? No? Oh, you're not here, Jace. Just come back for a sec. Right, because this is like, right, this is like exactly, that's like 2 over 1, right? And that's like 1 over 1. So I'm multiply straight across, it's 2 over 2.
Yeah, I just don't know how you got those numbers in.
Okay. So you did. Okay. All right. So what I just did for the big
Oh, you
question.
want to multiply them up.
Okay.
Yeah, okay, I thought you just multiply them out in case you get married.
So there's no time, sorry, we just times it all through, right? We're good now?
Yeah.
Okay.
Is that a
It's,
minus?
it's confused, no, it's confused, just like you gotta get it, just right, that's a minus, that's subtract.
Taking cosecant.
Yeah, so what you're gonna do is you're gonna find out what the value is on the left, find out what the value is on the right, and subtract them. Yeah, good, okay, I'm gonna ask for 4 volunteers, those 4 volunteers are gonna tell me those 4 answers. What is, 10 of 30, please? Brad, go. Let's just check to make sure he's right. When you see a 30-degree, right, opposite over adjacent 1 over root 3, awesome. Okay, sine of 45, Liam, go.
What?
Over root 2. Awesome. Okay, cosecant 45. Yeah, go ahead. Root 2. I'll do that as 2 steps, that is right. Okay, so 1 over sine 45, which turns into 1 over root 2. Great. 1 over root 2, which is root 2. Thank you. Okay, and tan 60 is equal to what? Some 4th person, please? Yeah, go ahead. Root 3. Okay, so it's like root 3 over 1, which is just root 3. So that's root 2 times root 3. And here we have 1 over. That's weird. Okay, now, Liam said he forgets how to rationalize. How do you times root 3 times root 2? What does that turn into? Root 6, okay? So this is going to be then 1 over root 6 minus root 6. This is like a math teacher's dream, this question. I love it.
Between cosecant and tan, it's a multiplication, not a minus.
Yes,
You said it
How
was
about
a
a
minus.
minus?
no, this is a minus. That's a times.
They look exactly the same.
Okay, one is like this, one is like this. You know, that's the right question, Nicole, or you good? Okay, so I have 1 over root 6 minus root 6. How did I deal with that? I don't recall that from when we did this. Go ahead.
You do the root 6 thing where you multiply the 1 over root 6 by root 6 over root 6.
Very good. So this is going to turn to root 6 over 6 minus root 6, too many 6's. It's not a devil's triangle. Okay, how do I deal with that now? Oh. So I do, thank you for asking. 1 over root 6 minus root 6. So remember we did this before for rationalizing, you just times it by 6 over root 6. We're going to times by the same thing, top and bottom, so I times it by 1, right? So the advantage of this now, we can have a whole number in the denominator. Because right, root 6 times root 6 equals 6. Right?
I forgot that.
Okay, that's all
So
right.
when 2 roots are multiplied, they just become the number?
Yeah, because think like if you're taking the square root of 5, that'd be something messy. And if you times it by itself, it's just the square roots are gone, right? Yeah, right.
And so that MCR bottom of the sample equals
Yeah. But just an easier way to think when you're flipping a fraction, it flips, right? Like that's. Okay. Now to finish this one off, because I know you guys want to get this over with, as I do, I'm going to call that then root 6 over 6 minus 6 root 6 over 6. And that's going to be roots. No, I shouldn't do that. And I was okay with what happened here. We just got a common denominator then of 6, so I'd multiply the top by 6 and the bottom by 6. Yeah. So it's going to be. It's called rationalizing, right? Okay, right? So it's whatever, in order to get rid of the denominator, make the whole number, we're going to multiply the numerator and the denominator by that, just to get rid of the square root. And that's why your calculator is like root 2 over 2. Right, so think with root 6 times root 6 is just 6, right? So I've got a.
Because 6 times 6 is 36.
So this is, okay, let's start. Alright, you okay with that? Yes or no? Okay, so square root 36 is just, what I did, I just went from there to there.
The square roots just stay the same. Square root, just right hand side, square root, right. Yeah, you go any further than that.
You factor if you want.
Basically, why couldn't you write -5 and?
Oh, goodness, whoa, goodness, you gotta move. Whoa. Oh, wow. Since people are attacking me. Up, up. Is that attacking now? No. Okay, because think of this is like, think of it this way. If you have like, if that was like x, 1 minus x minus 6x would be negative 5x, right? It's the same logic behind that. Now, hold on, before I switch for face, think of like a number minus, one of something minus 6 of something is like minus 5 of something. You'll have a million of these to practice tonight. I want to get on to triangles if I can, though. We'll do one more of these at the end of the class. I'll take a break and go to triangles, and I'll come back to this because this is.
What are you trying to get to a rational?
I know. That's well. This is the thing. Yeah.
I don't remember learning how to rationalize. I agree.
Okay. We'll do maybe a little quick recap of that after. I'm gonna pause.
Yeah, that's.
Yeah. Okay. The -5 came
There's
from.
like a million sixes in
Yeah.
that 5.
Well, because think you're basically subtracting, right? I've like think of this. So what I did here, it's the same idea as if I do like x minus 6x, right? That would be negative 5x, right? It's the same idea here. You have like a root 6, and you're subtracting 6 of them. So it's like 1 of something minus 6 of something is like negative 5 of something. That's the same thing then. It's the same idea as this, right? So like, it's like a placeholder, right? It's like root 6 is like something minus 6 of those things. It's going to be negative 5 of them. All right, pause the video, then we'll get to a tricky question. Then we'll come back to review rationalizing. So I think you guys need that, and probably